I'll just pick one then. Absolutely, yes. Well, let's do like 8 and 9. Those are probably different enough that that'll kind of cover things. Sound okay? So when I say the reverse order of operations, basically I can do that whenever I have just like one kind of x. So I can't do it if I have both an x and an x squared, but in a problem where I just have one kind of x, reverse order of operations is perfectly appropriate. So the idea here is I'm just going to kind of get the x part by itself. So on 8, I will subtract 10 from both sides and subtract x squared from both sides. That gives me 2x squared is equal to 1. And then we'll divide both sides by 2. And then we'll square root both sides to get rid of the squared. Now, when we square root both sides, there's a couple of things we need to remember. So the first thing is when we square root both sides of an equation, it creates a plus or minus. When we square root a fraction, we can think about that just as the square root of the numerator over the square root of the denominator. And we like to do that because it makes simplifying things a little bit easier. For example, the square root of 1 is just 1. And the square root of 2 doesn't come out to be a whole number, so we'll just leave it as the square root of 2. But if you remember last year in your geometry class, you guys would have talked about how we don't like to leave a square root in the denominator of a fraction like this. So what we'll do is we'll just multiply the top and bottom by the square root of 2, whatever that square root is in the denominator. So the square root of 2 times the square root of 2 is the square root of 4. And that just simplifies down to 2. And that would be like our best version of our answer. Not that plus or minus 1 over the square root of 2 is the wrong answer. It's just not the best version of our answer. In the same way that like 2 over 4 is still the same thing as 1/2. It's just not as good of a version of 1/2, right? It's just an unreduced fraction. The same kind of thing here. Does that feel okay, Joe?
Yeah, thank you.
Yeah, sure. If we wanted to do 9, again, we noticed I just have one kind of x in the problem. So I'm going to start by just trying to get that x by itself. So we'll add 4 to both sides to start. And then we'll divide both sides. Divide both sides by 9. And then we'll square root both sides. So because we square rooted both sides, that creates a plus or minus. And because it's the square root of a fraction, I'm going to have the square root of 4 over the square root of 9. And that simplifies down to just 2/3. And then I can subtract this 3 from both sides. So I have -3 plus or minus 2/3. But those are things that are like terms, right? We could combine them. So I could do -3 plus 2/3. And -3 minus 2/3. Those are both things that I can do. To add those two fractions together, we need to make a common denominator. The common denominator in this case would be 3. So I'll multiply -3 over 1 by 3 over 3, making it -9 over 3 plus 2/3. So when I add those two fractions, I get -7/3. And then similarly, I'll have -9/3 minus 2, which gives me -11/3. that okay? Megan? So this and this one are equal. They're just not, one version is like an unreduced fraction. But plus or minus 1/2 is wrong. That is a different value than this. So like 1 over the square root of 2 is like 0.707 yada 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 on your calculator, which is not the same thing as 0.5, which is what 1/2 is. Is that what you're asking? Okay. Who else has questions from homework 7?
Mr. Kulik?
Yes.
I just had a question. When do you think our test is going to be?
Next week at the earliest. Like end of next week at the earliest.
Okay, thank you.
You're welcome. Walter? Number 5? Sure. Okay. So this one is just, I made a typo, which kind of made it impossible to do. So notice here that technically speaking, we don't have a polynomial because we have x's in the, or we have y's, a variable in the exponent. I just typed this in wrong. This is supposed to be 33x squared, and then the y is supposed to be not in the exponent. So it couldn't have been done with the way I'd written it. But if it's what I have intended, it's now going to be doable. So, Walter, we'll do this. We've established that we couldn't do it the way it was written. But what I had meant, rather than what I actually ended up typing, is doable. So let's do that problem. Sound okay? Okay. So the first thing I'm going to do is, since the directions are to solve this by factoring, it's got to equal 0. So I'm going to move everything onto one side. So I'm going to subtract 3x squared y from both sides. And then I'm going to subtract 6xy from each side. And then add 6y to each side. When I do that, I get 30x squared y plus 4xy minus 2y equal to 0. Next thing I'm going to do is, I notice that I have more than one variable going on here, which is potentially a problem. But if I look closely, there is a greatest common factor between each term in this polynomial. So each of the coefficients is divisible by 2, and each of the terms has a factor of y in it. So I'm going to factor out a 2y. So far, so good, Walter? Okay. And now I'm going to just worry about factoring the 15x squared plus 2x minus 1 part. To do that, I need to find the two numbers that multiply to give me 15 times negative 1, or negative 15, and then add to give me 2. Well, those two numbers are 5 and negative 3. Hopefully it wouldn't have taken too long to come up with that. So what I'll do is I'm going to replace the 2x with a plus 5x plus negative 3x. And that's going to allow me to make two groups. From the first group, I can take out a 5x. And from the second group, I can take out a negative 1. And if I look now, each of those contain a factor of 3x plus 1. So if I factor that out, I'm left with 5x minus 1. And now that I have it in a factored form, I can apply the zero product property and set each of these factors equal to 0 and solve each one of them separately. So if I divide both sides by 2, I get y equals 0. If I subtract 1 and then divide by 3, I get x equals negative 1/3. And if I add 1 and then divide by 5, I get x equals 1/5. So those are my 3 solutions for that problem. Walter, are you okay with that? Okay. I think that was the hardest one on that factoring section by quite a bit, because he had to do the full long factoring and then also had that greatest common factor in the beginning to take care of. Plus, I wrote it wrong, so you couldn't have even done it initially. So that's my fault on that one. You just got to laugh about stuff like that, right? You try not to make mistakes, and what do? You end up making mistakes. Joe?
I have a general question.
Sure.
On one of the homeworks, it said solve using the method of your choice. What method would you like?
So it would depend on the form that the things was written in. So I think is that on homework? Is it this homework or 8?
I think it's 8.
Should we move on and talk about homework 8 here for a bit? Megan? Sure. So Joe, if you come back and remind me about that when we get to homework 8, I'd be happy to kind of talk about what I would do in each of the situations and why.
That's okay. Thank you.
You're welcome. Again, because that's maybe the most important question, right? Now that we have a couple of different methods for solving, what to do when is pretty important. So Megan, the first thing I need to do, if I'm going to use the quadratic formula, which is what the directions say to do, is it has to equal 0. So that's my first step. Good with that? And then I'm going to apply the quadratic formula, so I know that A is equal to 64, B is negative 48, and C is 9. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll just kind of plug those values in. So I have negative of negative 48 plus or minus negative 48 squared minus 4 times 64 times 9 all over 2 times 64. I'm going to get out my calculator because I don't know that I can do negative 48 squared in my head. And then if I subtract 4 times 64 times 9, I get 0. Underneath the square root there. And the square root of 0 is just 0. And anything plus 0 is itself, and anything minus 0 is itself. So I really just have 48 over 128, where if I reduce that fraction, it goes down to 3/8. How's that sound, Megan? Okay. Are we ready to move to homework 8? Okay. So questions from homework 8? Anyone? Obviously Joe has one pending, but I figure that's a little bit more of a broad question. And I'm happy to answer that, but figured if anybody had anything specific to start with, we could certainly start there. Megan? 13, you say? Okay. So it asks us to solve this using the reverse order of operations. So the first thing I would do is subtract 22 from both sides. Again, if I'm doing the reverse order of operations, I'm trying to get the x by itself. And then to get rid of that 1/2, I'll multiply both sides by 2. Right? Multiplying by 2 is going to get rid of that 1/2. So far, so good. Now to get rid of the squared, we'll square root both sides. So a couple of things here. Because I square rooted both sides, I get a plus or minus. And because I'm square rooting a negative number, that's going to create an I. And I can drop the positive number. Okay with that, Megan? Or drop the negative sign, excuse me, is what I meant. And then I'll just subtract the 8 from both sides. Now an 8 can't combine with either a square root or an imaginary. So I'm just going to put the 8 out front like that. And then we could do a little bit better than the square root of 40. Remember that 40 is 4 times 10, right? So the square root of 40 is the square root of 4 times the square root of 10. And the square root of 4 is just 2, right? So the better way to write this would be plus or minus 2i square root 10. I wouldn't mark you down, though, if you didn't do that last piece of simplification. But if you were looking at like doing a multiple choice test on like the ACT or something, me thinks that this would be the answer, how they would format that answer, as opposed to the -8 plus or minus I root 40. Does that feel okay, Megan? So it was hard to hear you because you spoke quiet and there's a mask on, so I couldn't. Can you repeat that? So that's a 2i that's in front of it. But yes, that 2i needs to be there. Or I square root of 40. Like this I wouldn't mark wrong on a test. But if you had something that wasn't actually equal to one of those two, I would mark that incorrect. You know what I mean? So like if you turn those into decimals, they're actually the same decimals. So it's like if I have 2/4, usually we would want to write that as 1/2, right? We consider 1/2 simpler than 2/4. If I have the square root of 40, the simpler way to write that is 2 root 10. And the reason I can do that is because the square root of 40 is 4 times 10, and the square root of 4 is 2. So I can just write that as 2 times the square root of 10. And that's just what we've kind of agreed on as mathematicians. It's like a convention that those two values are equal, square root of 40 and 2 times the square root of 10. Just like 1/2 and 2/4 are equal. We just consider one simpler than the other. Did I answer your question? Okay. And I don't want to act like one of these is right and the other is wrong, because that's not the case. It's just one is the convention and one is not the convention. You know what I mean? So it's just writing it in the way that other mathematicians are going to expect. You know what I mean? Okay. Should we talk about Joe's question here for a minute? So it says, using the method of your choice, so when I look at 17, this is a situation where I could really use any of the three, right? I could use reverse order of operations because I just have an x squared. I could try to factor it. In this case, this one actually doesn't factor. Or I could use the quadratic formula because it's already in a standard form polynomial, so there's no real extra work to do there. So any one of those three is pretty appropriate. Factoring isn't going to work here. We'll talk later today as part of the lesson about we're going to create a test that'll tell us if something is not factorable right away. That's easy to do, but you don't know that yet. So 18, I cannot use the reverse order of operations because I have both an x and an x squared. So that one is out, but I could try to factor it. You could look at this case and it should be easy to tell that this one isn't going to factor because there's not two numbers that multiply to give us 25 and add to give us 12. So you'd be having to use the quadratic formula in this one. 19, similar story. You could try to, it's reverse order of operations is out, but we could try to factor it. It doesn't actually factor, so you'd have to use the quadratic formula. 20, because of the way it's formatted, the way it's currently written, I couldn't try to factor it or use the quadratic formula because it's not in standard form. It would be easiest to approach this as a reverse order of operations question. Now, you could multiply that all out. You could do the expanding, get it into standard form, and then try to factor it or try to use the reverse order of, or try to factor it or use the quadratic formula. That's okay to do, but to me that looks like more work than just using the reverse order of operations, which is what I would do in that instance. Is that what you're looking for? Is to just like a talk through of how to make what decision?
Yeah.
Okay. You're welcome. And again, that's an important question, right? We've presented a couple of methods. It's really important to know in which cases can I do something, which cases can't I do that, and what cases is it just easier to do one thing versus the other, right? So in general, if the leading coefficient is 1, I'm going to check to see if I can factor because that is super duper fast, right? If I can do the shortcut factoring on it, that's what I would prefer to do. Oftentimes that, it could be the case that it's not factorable, at which point I would go to the quadratic formula. And really the only time I'm going to do the reverse order of operations is if I have something that's formatted where it's in kind of vertex form already, or if I have a single kind of x, just like an x squared or something. But any other situation, I'm probably going to use the quadratic formula. Just to kind of summarize what I established there. Okay. We good so far? Okay. So let's go ahead and start today's lesson. So a couple of quick things that we can talk about. So last time we met, we talked more about solving. We talked about using the reverse order of operations to solve things. And then we talked about using the quadratic formula. And then we filled in this last little gap where we end up having to take the square root of a negative number and what we do in that situation. So at this point now we have methods that can solve any quadratic situation. They're all solvable for us. But there's a couple of things that the quadratic formula can tell us about what to expect either in terms of our solution set or in terms of the factorability of a quadratic, which are nice to have. So remember the quadratic formula. Well, I should probably write. So if I have a standard form quadratic that's equal to 0, the solution is negative b plus or minus b squared minus 4ac all over 2 times a. This part here is called the discriminant. And the discriminant can tell us quite a bit about the quadratic that we're looking at. So that discriminant can tell us the number of solutions and the type of solutions. So there's actually 3 situations here. So if the discriminant is a positive number, we're going to have 2 real solutions. So when I say solutions, I mean to that standard form quadratic that we're starting with, right? We're talking about solutions to this thing, right? That's what I mean. Just to be clear, if the discriminant is exactly 0, we're going to have 1 real solution. And really by that, what I mean is I'm going to get the same solution twice. So like if you remember, sometimes when we factor, we get things like x plus 2 times x plus 2. Right? We've had that happen a couple of times for us. You guys remember that happening? If we're trying to solve that quadratic, x plus 2 times x plus 2, we're going to get the same solution twice, right? We're going to get negative 2 for the first factor and then negative 2 for the second factor. We're going to count that as one solution because it's the same answer twice. So that's what I mean by one solution, is you're just getting the same answer twice. And then the third situation is if that discriminant is negative, in that situation, we're going to get 2 imaginary solutions. So let's say we have x squared plus 5x plus 2. Here the a is 1, the b is 5, and the c is 2. So my discriminant, 5 squared minus 4 times 1 times 2, is 25 minus 8, which is 17. Since that's greater than 0, I know I'd be expecting 2 real solutions. Okay with how we kind of use that discriminant? So I just plug the numbers in and see what I got, and then use the rule appropriately, right? So the 17 was the value for the discriminant, and I interpret that as two real solutions since it's a positive number. Yes?
When you plug your values in, do you put it into a standard form equation or into the rooted one? Does that make sense?
Not really. Can you try it again?
Like when you put your A and your B and your C, did you put it into the formulas that we talked about?
I plugged it into this.
Okay, that's, yeah, you answered it.
Okay, no problem. No problem. Okay. My other result we can use the discriminant to determine if our quadratic is factorable, which is nice, right? What do I mean by PS here? I mean a perfect square. So what are things that are perfect squares? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, etc. These are examples of things that are perfect squares. So like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared are examples of perfect squares. 18 is not a perfect square because if I take the square root of 18, I don't get a whole number back. Is everybody okay there? Which is really nice, right? So for example, if we go back to this quadratic, gave us 17, right? This was the same quadratic we did in the previous example. And since that is not a perfect square, I can say immediately that that quadratic is not factorable. So this is a nice check right away, right? We can tell immediately with one little calculation whether something's going to be factorable or not. Now, for the most part, if the leading coefficient is 1, I don't really need to do this very often, right? For the most part, I'm going to tell it's going to be faster to just check to see if it factors by inspection than it is going to be to plug this in and do the calculation. But if that leading coefficient isn't 1 and the numbers are quite large, or you're just not sure, it's like, ooh, did I forget one, or maybe this thing doesn't work? Once you start thinking it's not factorable, this is a nice confirmation for us, right? Because it's quick and it's pretty easy to do. So far, so good? Okay. Questions about either of these two rules using this discriminant? Whether looking at the number and type of solution or looking at whether a quadratic is factorable or not? Good. So the next thing I want to do today is we are going to use our graphing calculators to write a program. So if you guys have your graphing calculator with you and you want to take it out and follow along, I encourage you to do so. What we're about to do right now, unless you, for whatever reason, reset your calculator or your batteries die or something like that, this program will be on your calculator in perpetuity. I've put this PowerPoint that we're going to run through right now on our PowerSchool page under the Resources tab. So if you need to go back and reprogram your calculator, this PowerPoint is there and available for you. Everybody okay with that plan? Okay. So go ahead and turn your calculator on. And you're going to begin by pressing the Program button there in the middle. See the giant arrow that I have pointing to the Program button? So that your screen should now look something like this. I want you to arrow over so that you're on the New tab. See the tabs at the top? Arrow over so that you're on the New tab. And go ahead and press Enter. So you should name your program something. It needs a name. I'm going to name mine Quad, Q-U-A-D. But you can name it Rufus or Jeremiah or Helen or whatever you want to call it. I don't... You know, you do what you like. You know what I mean? I don't want to tell you what you got to name your program. You're the one that's going to be using it. I'm going to name mine Quad, though. To get the letters to type, if they're not automatic, I can't remember if it's automatically alpha locked there or not, but if you press the alpha button, and then you'll notice that above some of the buttons is a green letter. If you do alpha and press that button, it'll give you that letter. But this might be automatically set at alpha lock for the name. I imagine it probably is. So go ahead and press Enter after you've typed your name, and your screen should look like this now, where the program is titled Quad, and you have a colon with a blank space after it. So let's talk for a moment about what it is that we're going to program the calculator to do, okay? Just to give you an outline of what it is that we're about to do. So the quadratic formula is just a formula, right? What we need the calculator to do is to ask us to give it the values for A, B, and C. And then we need to take those values from A, B, and C and store it into a variable. And then we're going to use those variables to compute the quadratic formula, store it into a new variable, and then output that answer at the end. Okay with that idea? Those of you that are in a computer science class, maybe that phrasing sounds familiar. And if it doesn't, that's okay. It's not a big deal. We'll walk through all of this together nice and slowly. All you really have to do is follow directions to get this thing set up. And once it's set up, you don't have to really think about how to do it ever again. So the first thing that we're going to do is we're going to press the Program button again. That's going to open up a menu that looks like this. I need you to move over to the I/O tab. So now your menu looks like that menu on the right. And from the I/O tab, we're going to select the the clear home command. Should do that first. So now, once you've selected the clear home command, your screen should look now like that, where it should say clear home. And go ahead and press enter to move to the next line after that. So your cursor should be below the clear home statement. Anybody have issues to this point? What this command does is it basically just clears the screen so that it looks nice when it displays at the end. Okay. So the next thing we're going to do is we're going to press that program button again. We're going to go over to that I/O menu again. And this time we're going to pick the prompt command and then type the letter A. And then press enter so that your cursor should be on the next line under prompt A. Is everybody ready to go to the next step? Well, you're just going to repeat those two steps 2 more times, this time typing prompt B and then prompt C. So again, press the program button, go over to the I/O tab, select the prompt command, and type the letter B. And then do the same thing, except you're going to type the letter C. So after you've typed prompt A and prompt B, make sure you've pressed enter 1 more time so you're on the line right underneath prompt C. I'll give everybody a minute to kind of get there. Okay, so what the prompt command does, just to let you know, is it asks you, the user, when you run the program, for an input for value for A. So the A that we type in is the value A in our quadratic formula. The value for B we type in would be the value for B, and then the C is the value for C, right? So we're just telling the calculator what those 3 numbers are, so when it does the calculation, it knows what numbers to use where. Okay with that? Okay. Next up, we're going to type in the quadratic formula. Now, the quadratic formula has a plus or minus in here, right, in it. So we're going to have to do the formula twice, once with a plus sign and then once with a minus sign. Now, I'm going to do mine a little bit differently than what's typed here, because I'm going to use that fraction command that puts a fraction in my calculator so I don't have to worry about the parentheses. So I'm going to actually start by pressing alpha y equals. Oh, it doesn't let me do that here, does it? Oh, well. Psi, never mind. We're going to type it in the way it looks.
Can you get prompt or not for program or not?
You should. Hi, Jesse.
Yeah.
Thanks. Kalila, this is for you. No, you can, if you're on the screen with your cursor underneath prompt C, you just start typing in what we see here. Okay, so you don't have to do anything else. So you just start by typing the parenthesis and then negative sign and then B and then plus and the square root symbol and then the B and then the squared, yada, yada, yada. So the way you get the arrow, so notice here there's an arrow next to the D, is you're going to press this STO button that I have an arrow pointing to there at the bottom of the calculator, right above the on button. Did you guys see that? Right here. That creates the little arrow like that. And what that arrow does is it's going to store the value from that calculation into that variable. So D and E, or I'm sorry, D is where our answer is going to be to that first calculation. So that's what we're going to have that calculator output for us there at the end. Megan? Yes. Yes, and you need both of them. One of the parentheses is closing this parenthesis at the beginning, and the other parenthesis is closing the parenthesis under the square root. So you do need both of those sets of parentheses there. Once you've done it with the plus sign, you're going to repeat and type the exact same thing, except you'll have a minus sign in front of the square root, and you'll be storing into E instead of D. But it's almost the exact same calculation. Megan. Okay, so press second and then the mode button. That should bring you back to the home screen. So just like the blank screen at the start of your calculator. Is that okay? Nope, you didn't. Nope, so press program now. And then go over to the edit tab. And you should see your program name listed there. So press enter to select that, and it should be exactly where you left off. You're welcome. So nothing you didn't lose anything. That's okay, that happens all the time. And you're good, you're right back where you left off? Okay. No worries. I'm glad you asked. I'm sure that somebody else will do the same thing at some point, right? I press the wrong buttons all the time. It's okay. Tyler.
So when I put the exponent, it doesn't go up. It just
That's okay.
Is that
No. If it has caret 2 after it, that's going to be fine. That'll be fine.
As long as it doesn't include everything after it.
Yeah, no, so if you put a parenthesis around everything after it, it would all go into the exponent. But if it's not, if it's just caret number and then stuff, it'll just take whatever's immediately to the right of the caret symbol. Only. Unless you had 2 digits consecutively, like 23, it would interpret that as one number, 23rd. But as soon as it gets another operator, it's going to say, okay, that's where the exponent ends. It should anyways. If not, we'll find it pretty quickly and when we do some tests afterwards to make sure everybody's program is working correctly. Are we ready for the next step here? So the next step we're going to do is we're going to type the output command. So you'll press the program button, go over to the I/O tab, and select the output command, which is command 6, it looks like. And you'll type output 61D and then 71E. Just like it's written there on the screen.
Do you have to put the commas in yourself?
Those commas you should have to type in yourself. The comma button is right above the number 7.
Oh.
You're welcome. Okay. And then the last thing we need to do is put the stop command. So to get the stop command, you'll press the program button. And then from the CTL menu, the first menu you're in, you'll scroll all the way down almost to the bottom, and you'll see the stop command. Okay. Is anybody still working on getting their program typed in? Okay. So go ahead and press second and then the mode button to exit back to the main screen. The mode button's right next to the second button. And now we're going to press the program button. And from the execute menu, we're going to select whatever that program name that you just made was. So mine was called Quad. And then it should be on your main screen. It should say program and then whatever you named it. Press enter. Now it should say A equals question mark flashing at you, right? So let's do this as our I'm sorry.
Mr. Coolidge,
This is, yes.
can you repeat the last step after a stop, please?
Yeah, so just press second in the mode button, which should take you back out to the main screen of your calculator. So just like your blank normal screen, the mode button is right next to the second button. And then you're going to press the program button again. And from that first tab, you're just going to select your program name. And it should then say program and whatever you named it on the main screen. And then just press enter one more time.
Thank you.
You're welcome. So we're going to solve this quadratic equation here. So when your calculator asks you for the input for A, what number are we going to put there? 6. And what number are we going to put for B? 7. And what are we going to put for C? -3. So the output that my calculator gives me is, I think, 9 3s and then -1.5. If you didn't get that, please say something. Tyler? Okay. Can you bring your calculator over and show me? So keep the error code on there because that helps.
0.33.
Yep, those are the two outputs that my calculator has at the bottom.
Are you supposed to get rid of the question mark or just put the value after?
Just put the value after the question mark. That's the issue. And these are not on separate lines. So if we go in here, oops. So you see how there's not a colon here starting there? So that's not a big deal. That's easy to fix. We'll just press. Okay. There we go. That should do it. Try 6, 7. You're welcome. Did anyone else run into an issue when they tried to run their program?
Mr. Coolidge, I didn't get that.
Okay. This will be hard, Rochelle. What did it give you? Did it give you numbers?
Yeah.
Okay. Did it give you either of those two numbers?
No.
Okay. Can you put your camera on and hold it so that I can see your calculator?
Sure.
Okay.
I think I might typed in
The formula incorrectly. That's my suspicion as well. So if you got an output, but it wasn't the output that we had, okay.
Yeah.
Okay. Can you press the program button for me?
Okay. No.
And then can you go over to the Edit tab and press Enter? Well, I cannot see any of that, unfortunately.
Is it?
Oh.
Yeah, is it right?
Yeah, it just all washes out on me.
Well, I couldn't get I don't know how to put the slash marks. That's what I didn't put.
Oh, that's the division symbol. So you just
Okay.
press the division button in the where the slash mark was.
Okay, thank you.
You're
I think
welcome.
that was baby.
Okay. Yeah, let me know if that doesn't fix it.
Okay.
All right. We have one more thing that we need to check on our program before we're finished with that. So let's try doing this one. So go ahead and run your program again. I'm suspecting most of us are going to get an error on this, which is exactly what I'm hoping. And if you don't, that's okay. How many of us got errors? What does the error say? Non-real answer. Why? What does that mean? It has the imaginary ones in it. Now, your calculator can handle this. We just need to turn that option on. So go ahead and quit from that error menu, and then you're going to press the mode button. And you'll scroll down to where it says A plus BI, right next to the word real. And press enter to highlight A plus BI. Has everybody gotten a chance to do that? Once you've done that, press second in mode to exit back out and try to run your program again to solve that same problem. So we're solving the same problem. And now it should work. Where it says, right next to where it says real is the A plus BI. So move your cursor onto that and press enter so that that's highlighted instead of real. And then you can just exit out to the main screen and rerun your program. Megan. Show me. Come show me. Of course. You're welcome. Yeah, it's already highlighted. So it's fine. It's done.
Oh, so what do you do?
So you do exit back out. And we're just going to rerun your program with that same values. And this time it works.
Did you hit quit or did you just clear it?
I didn't do anything. I just pressed like program, enter, enter. And it just runs the program again.
So from the place you were just at, you hit program.
You never have to go back in there. Like once you've changed that setting once, it stays.
Oh, okay.
So yes, I press second in mode to get back to the main screen. But you won't have to go in and change that setting again unless you reset the calculator or something.
Okay, thank you.
You're welcome. And it won't affect anything else that you do, having that option, because if we talked about, like, the complex numbers are just an extension of the real. So everything that worked before will still work by turning that option on. We just also have the ability to deal with i's on our calculator.
Wait, Mr. Cook, I'm sorry. What did you do after it said in real mode?
So right next to where it says real should say A plus BI. Do you see that?
It doesn't say that for me.
What does it
say? Like in mode, all calculations must result in a real number.
Okay, what does it say next? Is there an option next to the real mode?
It just says above it quit and go though.
Oh. So go ahead and hit quit.
Okay.
And then now press the mode button.
Okay.
And you should see an option there that says real. It's down like halfway down your screen.
Yeah.
And right next to that should be the option A plus BI. Move your
Okay.
move your cursor so A plus BI is highlighted, and then press enter.
Okay.
And then do second and mode to exit out of this menu, and try to rerun your program on that same quadratic that gave us an error just a moment ago. Now it shouldn't give you an error.
Okay, thank you.
You're welcome. Okay. Everybody okay there? So let's practice using our using our program. Okay? So those of you that are working from home, in the content library, we're looking at the timed solving practice 1. Those of you that are here in class, all you need is your calculator and something to write with. You need your graphing calculator. We just programmed to do this. If you didn't do that during class, you'll have to program your calculator when you get home and try this on your own. Okay? So you need your program graphing calculator. You're going to be using your quad program on each one of these problems. So that program we just wrote, you're going to use to solve each one of these. What's up? Did the battery just die? That's okay. Well, you can just you'll do this at home. And let's you can try plugging it into a charger and seeing if it comes back real quick. That would be strange. Okay. So again, if you didn't have your calculator with you today, or you didn't get your program plugged in because you're too busy doing something else, 1, shame on you. 2, you'll just take this sheet home with you and try it at home after you program your calculator at home. You could watch the video that we made today if you need help, or you can just look at the PowerPoint, which is up in the Resources tab on our PowerSchool page. But we're going to do this, say, let's take 5 minutes and go through this guy. On your marks, get set, solve. So you're solving here. So you're just using that quadratic program over and over and over and over again. If you didn't have your program finished or you forgot your calculator, that's okay. Just do this at home. It's just 5 minutes. It came back. That's weird. I don't even know what to say.